there is also something called DevSecOps. So that's what we're going to take a look at today. So let's start off with it. First, let's start off with the introduction. So if you know what is DevOps, you can easily understand what is DevSecOps. So first, let me give you a brief about DevOps and then move ahead with DevSecOps. So DevOps is basically a combination of the development process and the operations process of a software development lifecycle. So this software development lifecycle obviously has multiple parts. The main two parts are the development and the operations part. Development part is basically creating the application, testing it, building it, and all that. Operations part is releasing it to a staging environment and then deploying it to a production environment, and then running it in operation and also monitoring it. So now these two are separate. So sometimes there will always be that bridge between the development team and the operations team, and sometimes the bridge gets broken and there is no proper work around it. It might run in the developer's machine, but it might not work on the server. So for this, to solve this, DevOps came in. So the entire process is automated. That is, once your code is pushed, it will automatically get built, tested, and also released, deployed, and finally once all that is, it will be monitored. So now it is basically combining these two teams together and making them work better. If this process is automated, and from the building stage till the monitoring stage, if it is automated, then in that case there won't be any dependencies which are different. They will be the same. So now coming to DevSecOps, in DevSecOps you get about built-in security, not security that functions as a perimeter around apps or data. If security remains at the end of the development pipeline, organizations adopting DevOps can find themselves back to the long deployment cycles that they were trying to avoid in the first place. That is, if you finish off your DevOps lifecycle, and once your software development process starts, and once your software development lifecycle ends, and then you concentrate on security, again it will take a lot of time to complete that. So the main purpose of DevSecOps is to integrate security inside of the DevOps lifecycle. So when the software development lifecycle goes as is, the security also should be implemented at the same time. So now, what are the advantages of safety measures in DevSecOps? So what are the advantages of DevSecOps which is not provided in DevOps? So greater speed and agility for security teams. So obviously every major company has a security team which ensures that the applications which are creating, the data stored, are secure. So now, if the security team is integrated with the DevOps lifecycle, obviously they'll have a greater speed, and at each stage of the software development lifecycle, they can ensure that the maximum security is provided. An ability to respond to change and needs rapidly. So again, DevOps is mainly for this purpose. You can basically release every single day. You can make changes quickly. You can respond to a certain bug. So the same thing goes with security team. They can respond to a security bug immediately and make that change even more faster than before. But better collaboration and communication among teams. When you bring in together all these teams in one single process, it obviously makes it better to collaborate and communicate. Automated builds and quality assurance testing. So this is under DevOps only. So it's not just DevSecOps. This and even better collaboration and communication among teams. Even these two comes under DevOps. So they are a common feature or a common advantage. Early identifications of vulnerabilities in code. So basically you can identify the security issues or the vulnerabilities in the code even before building or testing it, or while building or testing it. Team member assets are freed to work on high value work. So basically if the software development lifecycle is not in a process, then the team members of the software developers, they have to work on many more side tasks, not just development. They'll have to make sure that the build is ready. They'll have to make sure that whatever they are doing is secure enough. Also, they'll have tasks of provisioning servers so that they'll be able to run these applications and check it out. So now if it is a completely automated process, they don't have to worry about that. They'll have to worry about the code they are writing, and once the code is written, they can just push it into the DevOps pipeline and check out for themselves, because it will automatically get built, tested, and they can check it out in the QA or staging server. So now this is a basic image I wanted to show. You can see development, security and operations team. So once you develop the product and it's in the staging environment, the security team obviously looks into the application and tries to make it more secure, and then provides it to the operations team, and what they do is they make it live. So now what if these three teams are clubbed together in a way that they need each other in the process which goes on and on. So now the software development lifecycle never ends, because there is always certain feedback coming out, and there is always room for improvement, and there is always room for more bugs. So now the developer completes his application by finishing off his programming part, sends it to the security team. The security team checks it out, catches out vulnerabilities, then they do whatever they want to do to establish even more security, and then they push it to the operations lifecycle, which they basically release it to the production environment, and then it gets monitored, and there is a bug, and if there is a bug, that will be sent to the developer. So it's built, secured, released, then monitored, then that bug is seen by the developer, again that bug is solved and sent to the security team, where they check whether it is secure enough. So this process goes on and on. So now, why do we need DevSecOps? To maintain short and frequent development life cycles, integrate security measures with minimal disruption to operations. So now the main part of DevOps is to make quick releases, or to make the development life cycle faster than before. So usually it takes 5 to 6 months if it is a large application, because they have to plan it, then they have to figure out what should be coded. So they'll have to figure out the classes, they'll have to figure out the UI design for the application, they'll have to figure out everything before starting off with it. Once everything is done, then they start off with the code. Once that is done, only then they move off to the next part. So it basically works on a waterfall model. But if it is DevOps, in that case, you can basically make sure that you finish the product as soon as possible. Then you can slowly improve the product by releasing certain updates every single day. You don't need to update a huge major update once in a month, which shows minimal change, but instead you can just make smaller changes every single day. It eventually becomes a larger change, because that's more faster, that's more easier for the users. Users will rather take small and meaningful updates every single day, rather than a huge update which doesn't make much difference. So now, by ensuring the security is present during every stage of the software development lifecycle or the software delivery lifecycle, we experience continuous integration, where the cost of compliance is reduced and software is delivered and released faster. So instead of pushing the security stage at the very end of the DevOps lifecycle, in this case, if security is present in every single stage, so once the code is ready, if the security team does their security checks, once it is built, tested, and after that, once it is when it is going to be released, or when it is in the staging environment, so in all of these stages, the security team is right with the operations and development team. So in this case, it's even more faster than a normal DevOps lifecycle, and the cost of compliance is obviously reduced, and you can deliver your software even faster. So now the main difference between DevOps and DevSecOps. So in DevOps, it's basically development, IT operations, and application delivery. You develop it. Once the application is developed, tested, and it's ready to be released, they put it in a staging environment where they do all the testing. They check out with certain users if it is good and well enough. If the feedback is positive, then the application is delivered, and this process goes on and on. The only difference between the DevOps and the DevSecOps process is that there is security embedded in this process. Security is not a separate aspect here. Security is embedded within the software development lifecycle, and that is the only difference. Over here, there is not much differences. So now, how does DevSecOps work? A developer creates code within a version control management system. So let's consider the version control management system as GitHub. So a developer creates code and pushes it into a GitHub repository. So now whenever there is a change made by the developer, it is committed to the same GitHub repository. Another developer retrieves the code from the GitHub repository to his local system and carries out analysis of the static code to identify any security defects or bugs in code quality. So now a developer pushes it into GitHub, another developer retrieves it and checks for security vulnerabilities or defects or bugs. So now once that is done, an environment is then created using an infrastructure as tool such as Chef, or it can be CloudFormation, or it can be Terraform. So this particular environment is just for testing. So the application is deployed. So the application which got tested for security defects or bugs will be basically the developer will make sure that does not exist, and then they try to test it out. So they create an environment where they deploy the application, and all these security configurations with the developer ensured should be available or applied to that particular system, to that particular server. And now they test it out. So once everything is fine, when there is no security issues, then they move ahead with it. Now a test automation suite is then executed against the newly deployed application, including backend UI integration, security tests, and API tests. So now you can get an automation suite. You can also use Selenium, which is also again automatic testing tool. So now you obviously have to test every single part of your application. There should not be any loophole or gateway for hackers or unauthorized access to be they shouldn't be let to easily enter your system. There should never be a loophole. So in that case, you'll have to test and you'll have to security check all of the parts of the application. So from the backend to the user interface, to the integration, to security tests, and also API tests. So all of this is done in an automation suite or test suite, obviously. And if the application passes these tests, it is deployed to the production environment. Once the written tests are all cleared by the application, even if one test does not pass, they do not deploy it. They finish the let's say they find out that there is a problem with the API. Where they log in, there is a small loophole in which you can basically do simple attack and log in into the account. In that case, what you can do is you will not have to deploy it immediately. You'll just have to take it and make sure there is make sure you change the code, or make sure you change your API's programming. And once that is done, you again do the test, and once all the tests passes, it gets deployed to the production environment. So now this new production environment is monitored continuously. Obviously, when everything is done and the application is hosted in the production environment where the client can start using it or the customers can start using it, now a monitoring tool always runs on these servers which the application is running on. So now every single aspect, every single tiny issue is noticed by the security or the monitoring tool which is running on the server. Nagios is one of those tools, so you can use Nagios to identify any active security threats to the system. So once all of this is done, the final part is monitoring and finding out whether there are any security threats. If there are any, again it is given to the developer and they make changes to the code, and this entire process is repeated. And you can basically, the beauty of this is you can basically make this entire process automatic, where you can just include steps where you approve or disapprove of certain tests. For example, if the tests fail, they obviously revert back, but let's say the environment is not completely created, but the application is trying to deploy itself, obviously it won't work. In that case, you can have a part where you can get a button which says approve or disapprove this particular step, and you can check out and if it is right and the environment is available successfully, then you can just click on approve and the application gets deployed. If not, you can just disapprove and create the environment once again, or create the template once again. Okay, so we've seen that. Now I just wanted to introduce you to the technology stack. So now, coming from the first part, which is going to be the plan and develop stage. So first you obviously plan the application, so that's fine. Every company plans. So now the development stage. So first you'll have to decide the repository which you're going to use for your application, and also a work management tool like Jira. So now once that is chosen, next you come to build. So obviously you'll have to choose the appropriate building tool. If you're using Java, you can go with Maven. You can go with MS Build if you're using .NET. If you're going with an Android application system, you can just go with Gradle. And then store artifacts. Obviously once the build is done, for example a Java application build is done, and you get a jar, a file and a var file, and you want to store it somewhere before it moves on to a testing tool. So now before it moves on to a testing tool, you will have to store it obviously as an archive somewhere. So you can use Maven or Artifactory, or there is Azure Artifacts, Nexus, Archiva. So you'll have to choose the appropriate artifacts tool which you want to use. Next comes the testing tool, which is Selenium, Cucumber, JUnit 5. So you can just choose one of these automatic testing tools or automation suites and then use it. And for security, you can go with SonarQube. So SonarQube is for quality assurance of the code. It also finds security bugs. I do not know much about the other tools, but obviously Qualys or OpenVAS, Contrast. So these tools are mainly used for the purpose of securing your code and securing your application. So this is the part where the DevSecOps part comes in over here. So if you remove the security part, and if you directly finish testing and go to deploy and operate stage, in that case you do not have security embedded within your DevOps stack. So in the middle you can see there is continuous integration and continuous delivery. So in the left side you saw all the major tools, right? So you have plan and develop, you have build, store artifacts, test and secure. So which is the tool which makes all of these tools connected? So once you develop and push the code into the GitHub repository, the Maven tool should basically the Maven tool should understand that new code is uploaded, and it should push and automatically build it and automatically push it into an artifactory. Then the testing tool will automatically pull that artifactory and test it out. So now this process should be automatic. You should not be involved in any of this in between. You will just have to upload your code, and this process should automatically take care. So now to do that, you need a continuous integration and continuous delivery orchestration tool, or a CI/CD tool, which basically connects all of this and makes it happen. So now you have tools like Jenkins, Bamboo, there is Azure DevOps, there is TeamCity. So all of these tools are required for this exact process to connecting all of these tools together. And at the bottom you can see there is container and container management. So basically you can have one server in which you have small pods or small containers. Inside you can host your application's different features, or you can basically create a microservices architecture. You can use Docker for that purpose, and Kubernetes to basically control and orchestrate all of the available containers which got created in Docker. So now once it is secure, everything is done in the left side of this particular stack. Now coming to the right side, the next part is continuous delivery. So continuous integration is done where the code is uploaded and it is tested and it is secured and it is ready. So now coming to the right side, deploy and operate. So first you have Puppet, SaltStack, Ansible and Chef. So you need a configuration management tool, which is a central tool which manages all the servers in which your code is going to be hosted, or in which your website or your application is going to be hosted. So now when it is going to be hosted, let's say you want to update a configuration change in all of those servers. So now instead of going to each server and updating or running the configuration file, you can just push the code to a configuration management tool like Chef or Puppet, and then these tools will basically run the configuration file in all the 100 servers which you have. And I think that's the easier part over here. You don't have to go to each of these servers and run a single configuration file. That will take a lot of time, but if you just upload it to a central system like Chef or Puppet, and that will take care of that. So now once that is done, the application gets hosted in a tool, let's say in the servers. So the servers can have Docker within them. So it is hosted right now. Now coming to monitoring, this is the last stage. So now coming to monitoring, you can use the ELK stack, Splunk or Nagio, Sensu, Neuralink. You can just monitor all of these servers which are currently having the application in them. Okay, so this is the monitoring stage. The monitoring is always done. So now the last part is scale. So scale basically means the servers which you have. So as I told you, you have hundreds of servers. You use Chef to basically run configuration files on them. So where are these servers available? So you can use a cloud platform, which is much better than using your on-premise setup. You can go with VMware or GCP or Azure or Amazon Web Services to host your website online. So you can basically have multiple servers, and all those servers can be controlled by a Puppet or a Chef configuration management tool, and you can install a monitoring service in all of those servers by creating an AMI, which obviously has or creating a copy or a template of a server which has the monitoring tool within it, and you can just create a similar server every time you try to create a new one. So I think I've pretty much covered all the tools over here. So finally, let's look into the best practices. DevOps is about the speed of delivery, and security should not slow it down. So obviously DevOps got involved with the so DevOps is growing because it makes the development life cycle even faster. It is, and the security should not slow that process down. So that's why DevSecOps came in. By embedding automatic security controls and tests early in the development lifecycle, you can ensure delivery of your applications. You can ensure faster and quicker delivery of your applications. You're only adding security to your workflows. By using tools that can scan code as you write it, you can find security issues early. This can be very efficient and save a lot of time. While you're writing code, if you find security issues and correct it then and there, that is obviously better than finding it later when you're going to release it to a staging environment. Usage of threat modeling is helpful. Using dynamic data protection protocols will help identify the risky events occurring across your infrastructure and to build the necessary protection into your DevSecOps workflows. So basically, if you have, obviously you'll have an application which requires data to get updated and retrieved and all that. So obviously you're going to protect your data of your application, and to protect that, if you're using dynamic data protection tools, which basically will help you identify these risky events, for example SonarQube, and in this case it'll provide or it'll give an extra protection to the complete workflow which you are creating. So these are some of the best practices. First one is embed the security controls and tests in the development lifecycle itself. Second, use tools to identify security issues and make security checks while writing the code itself. Third, usage of threat modeling. That is, you should obviously identify threats involved in your application, and you can use dynamic data protection tools like SonarQube, and that would be a lot helpful. So I think I've come to the end of this session, guys. So make sure to subscribe to our YouTube channel. I hope you liked this video, and I hope you like all our other videos, and make sure to leave a like. If you like the videos, please subscribe so that you can check out our upcoming videos. Every single day we upload multiple lives, and also we upload certain videos, or you can go check out our older tutorials for AI, ML, AWS, Azure. So we have all kinds of tutorials, you can check it out. Or if you want to contact us regarding your career or certifications, you can drop a mail to sales@intellipaat.com, or you can just open our website, and at the right bottom corner you will get a chat box in which you can start chatting, and we'll contact you immediately. So thank you for attending the session. Meet you in another one.